Welcome YouTubers to another episode in my Grammar Hero series. In today's video, I'm going to be working out arithmetic reasoning practice test questions from a website called ASVABpracticetest.com. In my opinion, you should take this practice test yourself first and then watch this video for anything that didn't quite make sense to you. In case this is your first time finding my YouTube channel, I also quickly want to mention that I also created a website called mastertheasvab.com. There you can create a free basic and premium account, which will enable you to take more than 10 different practice tests. All that said, let's go ahead and get started with today's video. Question 1 says, there are 5 blue marbles, 4 red marbles, and 3 yellow marbles in a box. If Jim randomly selects a marble from the box, what is the probability of selecting a red or a yellow marble? So on the ASVAB, you're going to have some very basic probability questions of this nature. And to deal with them, you need to know a few things about basic probability. First, you want to know that probability is usually represented with P. And probability is always between 0 and 1. If probability is equal to 0, that means there's no likelihood of something occurring. And if probability is equal to 1, you know that that event has a very high likelihood of occurring, almost certainly occurring. Similarly, I want to point out that probability, which again I'm representing with P, is always the desired outcome. And I'm just going to write desired since I'm using a pen here, over the total possibilities. Okay? So again, probability for very basic probability problems is calculated by finding the desired outcome over the total possibility. In this case, it's pretty easy to figure out what's what. So in total, there are 5 plus 4 plus 3 different types of marbles. 5 plus 4 is 9. 9 plus 3 is 12. Okay? So in other words, there are 12 different possibilities. If you reach into the bag of marbles, you have 12 different total outcomes. Similarly, the question tells you what the desired outcome is. What's the probability of selecting a red or yellow marble? Again, you just simply take those. There's 4 red and 3 yellow, and add them up. 4 plus 3 is 7 over 12. And as you can see, the probability in this case is 7 out of 12. We can't reduce this any further since there's no common factor among 7 and 12. So our final answer is 7 over 12. As long as you know these two things about basic probability, you should be able to get any of these questions right. Okay, so that's that one. And in light of the fact I'm using a special piece of software to be able to write on the website, I am going to have to use the list to keep track of where I'm at. So just bear with me in that regard. Question 2 says, if Kayla left a $10.47 tip on a breakfast that cost $87.25, what percentage was the tip? So to figure this out, we got to do some division. Namely, we got to do $10.47 divided by 87.25. Now, again, all fractions can be regarded as division. That is, you can read this as 1047 over 87.25, or you can read this as 1047 divided by 87.25, which will give us the percentage of the tip. So let's go ahead and start setting this problem up. Again, as I mentioned, we're going to be doing long division. We're going to do 1047 divided by 87.25. Now, if I'm not mistaken, most people learn how to do long division, including with decimals, in 4th grade. So if you got to this point and you didn't know how to proceed, That's okay. Again, this is a 4th grade math concept, so let's talk our way through it. Here's how you do long division with decimals. If the decimal place is only inside this division bracket, which is right here, such as it is in 1047, you can proceed as you normally would doing long division. If, however, the decimal is outside this division bracket, such as it is in 8725, you have to shift the decimal place outside the division bracket and a corresponding number of times inside the division bracket. So let's see what that looks like. Again, 8725 is outside the division bracket, so I got to shift this 2 times, and I'm going to do that a corresponding number of times to this one, 2 times. So in reality, the problem I'm working out is this: 8725, or 8,725, and 10,047. Okay? And since I shift the decimals a corresponding number of times, I don't have to worry about the decimal placement just yet. Okay? So now I'm asking myself, how many times does 8725 go into 1047? It doesn't. So what I have to do is add a 0 here, and by adding that 0, that's going to prompt me to put a decimal place right there. Okay? Now the question is, how many times does 8,725 go into 10,470? Now, you want to be smart as to how you do long division. Personally, I like to use multiple choice answers to help guide my work. I notice this starts with 8, this starts with 1, this starts with 1, this starts with 1. I know, let's say this was 8,000. 8,000 would only go into 10,000 one time. 8,000 times 2 would be 16,000. So we know that this is going to start with a 1, and this answer choice, therefore, is illogical. So we're going to do it once. 8,725 times 1 gives you 8,725. So we're going to subtract. You can't do 0 minus 5. We have to borrow. This becomes 6. This becomes 10. 10 minus 5 is 5. 6 minus 2 is 4. 4 minus 7, again, we can't do because that is too small. We have a 0 to borrow there, so we can't do that. So I'm going to borrow this 1. That's going to become 0. This is going to become 10. I have to borrow it one more time. This is going to become 9. And this is going to become 14. 14 minus 7 is 7. 9 minus 8 is 1. 0 minus 0 is nothing. Okay? So as it stands, we have 1745. Now we're asking ourselves, how many times does 8,725 go into 1,745 times? It doesn't. We have to add a 0, but we're not going to add a 0 up there since we're allowed to drop down a 0. Now the question is, how many times does 8,725 go into 17,450? Now think about this. If this was just 8,000, you'd be asking yourself, what times 8,000 would get you close to 17,000? Of course, the answer would be 2. 8,000 times 2 would give you 16,000. 8,000 times 3 would give you 24,000. So without doing any work, I'm almost certain that this is going to be 2. But just to prove it, let's work it off to the side. 8,725 times 2. 5 times 2 is 10, carry the 1. 2 times 2 is 4, plus 1 is 5. We can see it's already starting to match. 7 times 2 is 14, carry the 1. 8 times 2 is 16, plus 1 is 17. Therefore, 8,725 times 2 is 17,450 with no remainder. And therefore, we know that if Kayla left a tip in the amount of $10.47, that would be equivalent to 0.12, which is the same as 12%. Okay, so that's that one. Again, to be successful on the ASVAB, you have to be comfortable doing, or to be successful on the arithmetic reasoning section of the ASVAB, I always like to say this. You have to be comfortable doing addition, subtraction, multiplication, and division. including with decimals and fractions. If you can work with decimals, fractions, and all those other skills, this section will be easy for you. So I think in this practice test there's going to be multiple instances where I have to do division and multiplication with decimals. Just by watching this video and understanding exactly what I'm doing, you should be that much closer to achieving a better score. So just pay attention and you'll get there. Question 3 says a phone company charges $2 for the first 5 minutes of a phone call and 30 cents per minute thereafter. If Malik makes a phone call that lasts 25 minutes, what will the total cost of the phone call be? Or what will be the total cost of the phone call? So again, we have a 25-minute phone call, and we know the first 5 minutes, no matter what, is going to be charged. You're going to be charged $2. Okay, that leaves you, as you can clearly see, with 20 minutes of talk time during this particular call, albeit at 30 cents per minute. So to solve this one, we just need to take this and add that to the amount of, or the cost of the 20 minutes of talking at 30 cents per minute. So I'm going to do 20 times 0.3. Again, 0.3 represents 30 cents. Unlike the last problem where we did division with decimals, in this problem we're doing multiplication with decimals. As you can see, we have a whole number 20 multiplied by a decimal, 0.3. To do multiplication with the decimals, the trick is to shift the decimal place however many times you need to do to make the decimal a whole number. In this case, I'm going to make 0.33 by shifting the decimal place one time. So in reality, I'm working this out, 20 times 3, albeit with one decimal to shift back in at the end to the left. So let's work it out. 0 times 3 is 0. 2 times 3 is 6. Again, we have one decimal to shift back in at the left since we took it away up here. So I know for 20 minutes at 30 cents a minute, that's going to be $6. So in total, for a total talk time of 25 minutes, you were charged $6 plus $2, which is a total of $8. Okay? So again, very basic concepts on the arithmetic reasoning subtest. You just have to be able to do work with decimals and fractions. That's what's going to trip most people up on this section. So that's question 3. Now they do have the solutions on this website, which is a good thing. But that said, I think a lot of people benefit from someone actually talking their way through the problem and telling you how to set up these problems. Okay, so that's why I'm making this video. Question 4 says, if 10 inches on a map represents an actual distance of 100 feet, then what actual distance does 25 inches on a map represent? Whenever you see these scale problems, the first thing you need to think about is setting up a fraction that's going to allow you to cross multiply and solve. So this is what it looks like. Again, I'm going to put 10 inches on top. We're told 10 inches represents 100 feet. And in this next fraction, I'm going to keep the measurements the same. That is, I'm going to put inches in the numerator, which is this top number, and I'm going to keep feet in the denominator. So 25 inches, I'm going to keep that in the numerator as I did over here. And in the denominator, we don't know what that represents, so we're going to use x to represent the unknown value. And once you set this up enough times, you can go ahead and get rid of these measurements. And now the key to solving these problems is to cross multiply. That is, you're going to do 10 times x and 100 times 25. 10 times x is simply 10x. 100 times 25 is actually very easy to do. Now, some people would start doing this, 100 times 25. There's nothing wrong with that, albeit the fact that it's very time consuming. the easiest way to work with anything that's a power of 10 is to realize that you can do the mental math very easily. So 25 times 100. Again, when you're multiplying or dividing anything by a power of 10, so 10, 100, 1,000, 100,000, it's just a matter of shifting the decimal place according to how many zeros there are in the power of 10. In 100, there are 2 zeros, and the decimal place is right here in 25. So I'm just going to shift this decimal place 2 times to the right, 1, 2, which is going to make 25 times 100 be 2,500. Again, a large part of the people who score very high on the ASVAB are very good at identifying when they can use mental math to speed things up. Okay, so again, power of 10 is always something that you should feel confident doing mentally. So with that out of the way, we can go ahead and solve. Again, we're solving for x in this case, so I'm going to divide both sides by 10. This is going to cross out. Again, I'm going to have x equals 2,500 over 10, and I can just cross out these corresponding zeros, which will leave me 250 divided by 1. Anything divided by 1 is itself, so 250 divided by 1 is just going to be 250. Therefore, I know that if 10 inches on a map corresponds to 100 feet, 25 inches on a map corresponds to... Oh, I almost wrote miles there. What am I thinking here? 250 feet, which is this one right here. Whenever you see a problem with maps, distances, and scales, this is your setup. That's all you have to do. These problems will become automatic. You'll say, oh, I've seen that question type before. I got to set up cross multiplication, and I'm going to move on. Now, sometimes these cross multiplication products get very hairy, especially if they throw a decimal in there, but just work your way through it and you'll get the problem right. So that was question number 4. Let's go back to the list and work on question number 5. Now, these questions always are difficult for me. There are some questions that are difficult for some people and not others. This one always gets me, so just bear with me on my explanation on this one. Question 5 says, 5 years ago, Amy was 3 times as old as Mike. If Mike is 10 years old now, how old is Amy? So I always have to use a chart to solve these. Otherwise, I'm not very good at them. So I'm going to say this is their age 5 years ago, and this is their age now. Let me put Amy up here and Mike right here. So I'm basically going to use this chart to work through this problem logically. Mike, the problem tells us Mike is 10 years old now. Okay? And in addition, we know that 5 years ago, he must have been 5. Okay? That's simple. We can figure out Mike easily based on the information given. It said that 5 years ago, Amy was 3 times as old as Mike. 5 years ago, Mike was 5, which means Amy was 3 times 5, which would be 15. Again, we add 5 years to that. Now she is 20. Okay? No scary algebra. Just work your way through this problem logically. Again, it told you Mike is 10 now. 5 years ago, he was 5. 5 years ago, Amy was 3 times as old as Mike. 5 times 3 is 15. Add 5 years, that gets us to 20. Okay? So very simple problem if you know how to set up the chart and just do exactly what they're asking you to do. These problems get more difficult than this, but in short, that's how you want to set them up. You want to approach it with a chart so you can keep all of your work organized. So that's that one. And I do not like those problems. believe we're on question number 6. Let me just make sure. Yep, we're on question number 6. Number 6 says, at a used bookstore, Valentina purchased 3 books for $2.65 each. If she paid with a $20 bill, how much change did she receive? So far we've done division with decimals, long division with decimals, multiplication with decimals, and this problem is going to force us to do multiplication with decimals as well as subtraction with decimals. So in 6 problems of the arithmetic reasoning practice test, we've already worked with decimals that many times. If on your ASVAB, you're either going to be forced to work with decimals or fractions, so it's a good idea to be pretty proficient with both of them. But nonetheless, let's set this one up. She bought 3 books at $2.65 each. That's $2.65 times 3. Again, we're doing multiplication with a decimal and a whole number. As I mentioned previously, the trick to doing these is to shift the decimal to make the decimal a whole number. In this case, I have to shift the decimal 2 times. So in reality, I'm doing 265 times 3. And once I'm done doing that arithmetic, I'm going to shift the decimal place back into the left twice. So 5 times 3 is 15, carry the 1. 6 times 3 is 18, plus 1 is 19, carry the 1. 2 times 3 is 6, plus 1 is 7. Don't forget to shift your decimal back in twice. 1, 2. So in other words, the 3 books she purchased at $2.65 each was in the total amount of $7.95. Now we know she paid with a 20. So let's go ahead and set up the subtraction part of this problem. We're going to have $20 minus $7.95. The key to doing subtraction with decimals, in case you haven't seen it in a long time, is to line up your decimals and then start borrowing accordingly. So the way I like to do it is this. As I can see, I got 0 minus 5 I can't do, 0 minus 9 I can't do, 0 minus 7 I can't do, but this is 20 minus 7. So what I'm going to do is start borrowing accordingly. I can't borrow here, I can't borrow here, I can't borrow here. This is going to become 1. This is going to become 10. So now I can do 10 minus 7, but that said I can't do 0 minus 9, there's 0 minus 5 yet. So I'm going to borrow one more time. This is going to become 9. This is going to become 10. Now I can do 10 minus 9, but I can't do 0 minus 5 yet. I have to borrow one more time, and this is going to become 9, and that's going to become 10. Now I can do everything. 10 minus 5 is 5. 9 minus 9, 0. Drop your decimal place as it's lined up. 9 minus 7, 2. 1 minus nothing, 1. So in this case, the 3 books were purchased for a total of $7.95, excluding tax, of course. And if she gave him a 20, that would be 20 minus $7.95, which means she should get $12.05 in change in return. So that's that one. Again, we did multiplication with decimals as well as subtraction with decimals. Again, decimals and fractions are usually what trip people up. So that was number 6, I believe. Yep, let's go to number 7. All right, number 7 says Mia earns $8.10 per hour and work 40 hours. Charlotte earns $10.80 per hour. How many hours would Charlotte need to work to equal Mia's earnings over 40 hours? So the first thing we need to figure out is how much total Mia earns in a 40-hour work week. In other words, I'm going to do 810 times 40. And you might be saying to yourself, well, why'd you put the small number up top? That's because I know I have to shift decimal places in order to do multiplication with a decimal. Specifically, I have to make 810 become 810 by shifting its decimal place 1, 2 times. So in reality, I'm doing 810 times 40. albeit with two decimal places to shift back in at the left at the end. So let's go ahead and work this out. 0 times 0 is 0. 0 times 1 is 0. 0 times 8 is 0. I'm going to add a 0 since I'm starting this number. 4 times 0 is 0. 4 times 1 is 4. 4 times 8 is 32. Let's add. This is basically nothing plus this, so I'm just going to go ahead and copy this down and shift my two decimal places back in. 1, 2. So in 40 hours, as we can see, Mia earned $324. The question is, how many hours would Charlotte have to work to make this much money? So we're going to do 324 over 1080. Okay? And again, fractions can be treated as division. Namely, you can read this as 324 over 1080 or as 324 divided by 1080, which is what we're going to have to do. So I'm going to set this up to be long division, or for a long division problem. Since I'm going to be shifting decimals, I'm going to set it up to the left originally because I want to have this space to actually do the math. So this is 324 divided by 1080, and I dropped off the 0 there, which is no big deal. Now, as I mentioned earlier, you can do long division with decimals as long as the decimal's inside the division bracket. In this case, 324, the whole number is inside the division bracket, so we're good there. But that said, 1080 or 10.8 is outside the division bracket. So I can't proceed as I normally would doing long division. Instead, I have to shift this decimal place once here to make 10.8 108. And since I shifted it there, I have to shift it a corresponding number of times there. So in reality, and now that I have space, I'm going to show you this. I'm going to be doing this. 3,240 divided by 108. Okay? Now, a lot of people would probably not use these answer choices to help them solve this problem. But think about it this way. And I can see this. You should be able to see this once I mentioned it. These all start with 2, whereas this one starts with 3. Okay, and we're asking ourselves at this point, how many times does 108 go into 324? Well, I know 10 times 3 is 30, and I know 8 times 3 is 24. So just by pointing that out, you should be able to see that if you're good with mental math, you know the answer is going to be 30. That said, the best thing to do is to use these answer choices to guide your work. So off to the side, I'm going to do 108 times 30. And let's work that out. 8 times 0 is 0. 0 times 0 is 0. 1 times 0 is 0. Drop down a 0 before we start working on this. 3 times 8 is 24. Carry the 2. 3 times 1 is 3. Plus 2 is... Oh, did I make a mistake? Let me see. 3 times 8 is 24. Carry the 2. Yep, I did make a mistake. Let me start that over so that you can see it. Sorry about that. Again, the hardest part of the arithmetic reasoning subtest is doing all the mental math. By the end of the subtest, you should feel drained mentally. So let's redo that. Again, we're doing 108 times 30, and I know the mistake I made, so let's just start over from the beginning. 8 times 0 is 0. 0 times 0 is 0. 1 times 0 is 0. Drop down a 0 before you start doing anything with this. 3. 3 times 8 is 24. Carry the 2 over the 0, which is where I made the mistake. 3 times 0 is 0. Add 2. 1 times 3 is 3. As you can see, we have 0 0, basically 0 plus 324. So we know this is going to be 324. In other words, 108 times 30 is going to give you 3,240 evenly. So there's going to be no remainder. And we can see that our answer is just going to be 30. So that's that one. Again, use mental math to help guide your work. Work smart, not hard, and you should do pretty well on this test. Typically, if you're working hard, it's because you've made some mistake or some oversight. So question 8 says, Aisha wants to paint the walls of a room. She knows that each can of paint contains 1 gallon. Half a gallon will completely cover 55 square feet of wall. Each of the 4 walls of the room is 10 feet high. 2 of the walls are 10 feet wide, and 2 of the walls are 15 feet wide. How many 1-gallon buckets of paint does Aisha need to buy to fully paint the room? So one thing I want to point out right away is when you're dealing with square feet, you need to know that you're dealing with area. When you're dealing with cubic feet, you're always going to be dealing with volume. In this case, we're working on painting a room, excluding the roof and the floor. So it's going to look like this. Just bear with me. I'm drawing with a new pen here. Looks like this. That is to say, the height of all the walls is the same. It's 10, but the length and width, or the lengths of the room vary. And specifically, it varies like this. We have 2 walls, and I'm going to sketch them out individually. Those are the same, believe it or not, that are 10 by 10. So that one's 10 by 10. This one's 10 by 10. And then we have additional walls that are 5 feet longer that are 10 by 15. So in other words, this is what we need to do. I'm going to call this area 1, area 2, area 3, area 4. To find the total area, we're going to do area total equals area 1 plus area 2 plus area 3 plus area 4. That is, we're going to find the areas of these rectangles, add them all up, and then we'll know how much area Aisha has to paint to fully paint all the walls of the room. Area for a rectangle is always length times width. As you can see, we have that for all of these, and they're actually pretty easy to do, so we don't have to do too much arithmetic in this case, fortunately. Area 1, length times width, 10 times 10, 100. Area 2, same as area 1, length times width, 10 times 10, 100. Area 3 is 10 times 15. Again, we're multiplying 15 by a power of 10 with 1 0 there. So technically, you just have to shift this decimal place 1 time. So 10 times 15, we should be able to know very quickly, is 150. 10 times 15 for area 4 is 150. And again, to find area total, we're adding everything up. And it turns out that this mental math is also pretty easy to do. 150 plus 150 is 300. 100 plus 100 is 200. 300 plus 200 is 500. Okay? So we found all the area of the walls combined. That said, we're given this little curveball here. Half a gallon of paint covers 55 square feet of wall. So if half a gallon of paint covers 55 square feet, if you double that, and let me do this right on this Google ad here, 55 times 2, 5 times 2 is 10, carry the 1, 5 times 2 is 10, plus 1 is 11. If a half a gallon of paint covers 55 square feet, then 1 gallon of paint covers 110 square feet. Now, you can do 500 divided by 110 to figure out how many gallons of paint you would need, but it's also easier to do this one mentally. Let me show you, so that you can get accustomed to trying to figure out what the quickest way to solve these problems is. So this is gallons, and this is area. Again, 1 gallon, as we just worked out, covers 110 square feet. 2 gallons is going to cover double that. 110 plus 110 is going to be 220. 3 gallons, just add 110 to 220. It's going to be 330. 4 gallons, add 110 to 330. It's going to be 440. And 5 gallons is going to be 550. Much easier to do this mentally than to do 500 divided by 110, although they're both pretty easy. Okay, so the question is, how many gallons do you need? That means we're focusing right here on 4 and 5. If you get 4 gallons of paint, you're going to be short 60 feet. If you get 5 gallons of paint, you're going to have an additional 50 square feet with which you can paint. So the answer is 5 gallons. Again, this problem required you to understand how to calculate the area of a rectangle multiple times, and then it prompted you to double the gallon to make a full gallon, and then do some additional mental math to figure out how many gallons of paint you're going to need. Again, there would be nothing wrong if you did 500 divided by 110. And in fact, you can kick off a 0. Now the question is, how many times does 11 go into 50? And you would see that this would be 4 point something, which would prompt you to round up to 5. I just like looking at it this way. This way makes way more sense to me than doing the long division. I try to avoid division whenever possible. So that was question 8. Let's go on to number 9. Again, this is another basic probability problem. Now, my only beef with this practice test is this. If you get a basic probability problem right, it's going to throw a more difficult probability problem at you. It's not going to give you the same level of probability problem over and over again. So, that said, let's go ahead and just work this one out. We should know how to approach it since I mentioned it for the first problem. Question 9 says there are 4 red marbles and 8 green marbles in a box. If Emma randomly selects a marble from the box, what is the probability of selecting a red marble? So again, we know probability is going to be between 0 and 1, where if it's 0, that means there's no likelihood of that occurrence happening. And if it's 1, it's certain to happen. Again, we know probability is also the desired over the total possible outcomes. Okay, so in light of that, we can just fill this in. What is the probability of selecting a red marble? Again, this is our desired outcome, selecting a red marble. There are 4 of those, so we know that it's going to be 4 chances of the desired outcome occurring. And since there are 4 red marbles plus 8 green marbles in a box, we know that the total possibilities is 4 plus 8, which is going to be 8, 9, 10, 11, 12. At this point, you might be looking at your answers choices and not seeing this. That's because 3 can go into both 4 and 12. So you actually have to reduce this by a common factor of 3. 4 divided by 3. Did I say 3? What am I thinking? 4 is a common factor, so you have to reduce this by a common factor of 4. 4 divided by 4 is 1. 12 divided by 4 is 3. So 4 over 12 is the same as 1/3. Okay, so again, just bear in mind, if you get these probability problems right early on in the test, you're going to get something more difficult later on. So this is good practice now. If you go on my website and register for the practice test, you should notice that I've made an effort to make some practice tests very easy and some practice tests more difficult. Again, by taking 10 or so practice tests before you take the real one, you're going to realize that not everything's going to be easy and straightforward, especially if you're doing well on the test. So again, don't just take 1 or 2 practice tests, because you might get something like this, think you're ready for the test, and then the test throws something at you that's more difficult than this, and your score will reflect that accordingly. But that's question number 9. Okay, question 10 says Oscar purchased a new hat that was on sale for $5.06. The original price was $9.20. What percent discount was the sale price? So of all the formulas you need to know to do well on the arithmetic, reasoning, and mathematics knowledge subtest, I want to include this one, that is percent change equals the final amount minus the original amount over the original amount times 100. Okay, so this is one of the formulas you absolutely need to memorize, because when you get problems like these, it's just a matter of plugging things in and doing the very basic arithmetic. I did recently create a video that's completely devoted to this topic, so take a look at that if you need to. But that said, we're trying to find the percentage discount, or how much the percent changes when you go from 920 to 506. So let's set up our formula accordingly. The final price was the final sale price, so that's going to be 506 minus the original price, which is 920, divided by the original price, which is 920, times 100. So as you can see right away, I got to deal with 506 minus 920. So I'm going to work that off to the side. The way you do subtraction with decimals is like this. You take the bigger number, which is 920, subtract 506 from it, line up your decimals, and we know this result's going to be negative because 920 is bigger than 506. 0 minus 6 I can't do. I have to borrow 1 here. This becomes 1. That becomes 10. 10 minus 6 is 4. 1 minus nothing is 1. Drop your decimal in place. 9 minus 5 is 4. So right away, I know 506 minus 920 is going to be negative 4.14. And again, this is all over 920 times 100 hanging out there. Now, as you can see, the next step is to regard this fraction as a long division. That is, I'm going to do negative 4.14 divided by 920. Before I go any further, I want to point this out. When you're doing multiplication and division, you can use the signs chart if you get lost, and that's this. I ran out of space. Let me rewrite that for you. Let me make it a little smaller. So if you're doing addition or subtraction with negatives and positives, you can use this signs chart to figure out what the result, or the product or quotient is going to be. In this case, we're doing negative 4.14. So we start with a negative, divided by positive 9.2, positive 9.2. Therefore, I know the quotient, or the final result, is going to be negative. So we can kind of disregard this negative right here because we know it's going to be negative. But that said, let's go ahead and set up the long division. Again, this is one of those funky ones, so we gotta be careful as we set it up. We're doing 4.14 divided by 9.2. Now you may have noticed that I dropped off this 0 here because it's going to affect how many times I shift the decimal. This 0 is just a placeholder to keep 9.2 corresponding to 4.14. The 0 means nothing, so I dropped it off right there. And as you can see, I'm doing division, albeit with by a decimal divided by a decimal. And since this decimals outside this division bracket, I can't proceed as I normally would do in long division. Before I can proceed, I have to shift the decimal place one time to make 9.2 92. What I do outside the division bracket, I have to do inside the division bracket. So I'm going to shift this one time as well. So in reality, I'm actually working this out. Let me do it up here so we can have some space. I'm doing, let me give myself some space here. 414 divided by 92. Again, we got rid of those decimals. And it's 41.4. I just moved this decimal here. Okay, so sorry about that. Again, you can make mistakes transcribing your work. So be very careful, as I just noticed there. When you're dealing with decimals, things do get very messy. Now we're asking ourselves, how many times does 92 go into 41.4? It doesn't. It's too small. So I have to move on. And again, when you have this decimal hanging out in the middle of the number, you just bring it up you just bring it directly up in the same place. So now I'm asking myself, how many times does 92 go into 414? Well, again, 9 times 5 would give you 45. 9 times 4 would give you 36. I know 5 is going to be too big, so this isn't a logical answer choice. That said, this is a little over just 9. It's 92. So I know this is going to be a 4. Let's go ahead and do that. 92 times 4. See what that gives me. 4 times 2 is 8. 9 times 4, as I just mentioned, is 36. So 92 times 4 would give you 368. Subtract. 4 minus 8 I can't do. I have to borrow. From here, this becomes 0. This becomes 14. 14 minus 8 is going to be 6. 0 minus 6 I can't do. I have to borrow. This becomes 3. This becomes 10. 10 minus 6 is going to be 4. Now I'm asking myself, how many times does 92 go into 46? It doesn't, but I'm allowed to drop down a free 0. Okay? So I can drop down that free 0 since I'm working down here and not up here without having to do anything. Now I'm asking myself, how many times does 92 go into 460? Again, 4 would give you 36. 90 times 4 would give you 360. 92 times 5 will get you, or 90 times 5 will get you 450. So I'm going to say this is going to be 5. And again, my answer choice right here kind of leads me to believe that. Let's work it out just to prove it. 92 times 5. 5 times 2 is 0. Carry the 1. 5 times 9 is 45. Plus 1 is 46. So we can see that 92 times 5 is 460 with no remainder. Therefore, the percent change is negative 0.45. Again, we have negative divided by positive. Negative divided by positive, result's going to be negative. In other words, the discount decreased the original price of the hat from $920 to $506 in the amount of 45%. And again, that multiplied by 100 is still hanging out there. Again, we're multiplying by a power of 10. That just shifts the decimal place twice to make 0.45 just 45%. Okay, so that's that one. A lot of work to do that one, honestly. So hopefully you were able to follow along. Some of these decimals get really tedious, and you'll find yourself feeling as if you're lost in the woods on some of these problems, just because the test maker didn't realize that decimals get tedious. All Right, question 11 is a pretty good one. It says there are 2 pizza ovens in a restaurant. Oven 1 burns 3 times as many pizzas as oven 2. If the restaurant had a total of 12 burnt pizzas on Saturday, how many pizzas did oven 2 burn? So again, you're going to construct a very basic algebra algebraic statement to solve this one. 2 pizza ovens. Oven 1 burns 3 times as many pizzas as oven 2. So if oven 2 burns X number of pizzas, then we know that oven 1 burns 3 times that amount, which would be 3x. On Saturday, there were 12 burnt pizzas, so we let this all equal 12. So what this says is on Saturday, there were 12 burnt pizzas. If oven 1 burns this amount and oven 2 burns twice as much, this is how many pizzas are burned in total. And again, this is oven 1. I think I flipped that. This is oven 1. This is oven 2. That's going to be important to keep our work straight. Let's combine x and 3x to be 4x. Now we're just solving for x. Going to divide both sides by 4. This leaves us with x equals 12 divided by 4. 12 divided by 4, of course, is 3. Again, it's asking you how many pizzas did oven 2 burn. Well, this is oven 2 here. We know x is equal to 3. Therefore, we know oven 2 burnt 3 pizzas on that Saturday. Okay? So that's that one. Pretty good one. Let's move on to question number 12. Question 12 says Sophia is driving to Texas. She travels at 70 kilometers per hour for 2 hours and 63 kilometers per hour for 5 hours. Over the 7-hour period, what was Sophia's average speed? Okay, so a lot of people might think that they're actually going to be using the distance formula to solve this one. You're not using the distance formula. Instead, this is asking you to find her average speed. So we got to find the average. It's going to look like this. Average is going to be this. Again, we know how many total hours she drove, so we know everything's going to be divided by 7. And this is how I like to think of this problem. Again, total 7 hours. For 2 hours, she drove at 63 kilometers per hour, so that's going to be 63 plus 63. Again, that's hour 1, hour 2. And for the remaining 5 hours, she drove at, sorry about that. She drove 70 kilometers per hour for the first 2 hours, so that's going to be 70 plus 70 for hour 1 and 2. And then for the remainder of the trip, she drove at 63 kilometers per hour, so that's going to be 63 plus 63 plus 63 plus 63 plus 63 5 times. 1, 2, 3, 4, 5. Now it's just a matter of doing the math. Again, instead of finding the distance, using the distance formula to find anything, we're using the average formula to figure out what her average speed was. For hour 1 and 2, she drove at 70 miles per hour. For hours 3, 4, 5, 6, and 7, she drove at 63 kilometers per hour. We divide that total over how many hours, and that will help us find the average. 70 plus 70, you should be able to see, is 140. Again, 7 plus 7 is 14, therefore 70 plus 70 is 140. And 63 times 5 will get us this total. So let's do that off to the side. 3 times 5 is 15. Carry the 1. 6 times 5 is 30, plus 1 is 31. We got to add this total to this total, so that's going to be 315 plus 140. 5 plus 0 is 5. 1 plus 4 is 5. 3 plus 1 is 4. So again, the average is going to be 455 divided by 7. Again, all fractions can be regarded as division. So we're going to do 455 divided by 7, which looks like this. Okay, again, no decimals to worry about, so we're ready to go. We're asking ourselves, how many times does 7 go into 4? It doesn't, it's too small. How many times does 7 go into 45? It's going to be 6 times, because 7 times 6 is 42. 45 minus 42 is going to be 3. Drop down this 5. Now the question is, how many times does 7 go into 35? Well, 7 times 5 is 35. So we can see there's going to be no remainder. And to answer this question, if she drove at 70 miles per hour for 2 hours and 63 miles or kilometers per hour for 5 hours, that means she drove at an average rate of 65 kilometers per hour. So that's that one. Again, you may be noticing that you have to be good with long division, addition, multiplication, and subtraction to do well on this test. So let's go ahead and move on to number 13. Okay, 13 says Steven signed up to bring 5 gallons of lemonade to the company picnic. He has a 5-gallon bucket which contains 3.5 gallons of lemonade. How many pints of lemonade will he need to add in order to fill the bucket? Okay, so this is an interesting problem. He has to bring 5 gallons. He has a 5-gallon bucket that's only 3.5 gallons full. So the first thing I'm going to do is take 5 gallons and minus 3.5 from that. Again, 0 minus 5 we can't do. We have to borrow. This becomes 4. This becomes 10. 10 minus 5 is 5. Drop your decimal in place. 4 minus 3 is 1. So if his bucket has 3.5 gallons in it, he needs an additional 1.5 gallons of lemonade to bring the total 5 gallons. In this case, we're being asked to find how many more pints are in those 1.5 gallons. So the way I like to think of it is this. There are 8 pints per gallon. So 8 pints per gallon, which means there are 4 pints per half gallon. So we can do this one mentally. Again, he has 1 gallon left to bring, 1.5 gallons left to bring. So that 1 gallon is going to be 8 pints. And that half gallon is going to be 4 pints. 8 plus 4 is 12 pints, which is right here. Again, you do have to know some basic conversions between measurements. In this case, you had to know that there are 8 pints per gallon, which means there are 4 pints per half gallon. And you can simply do the math from there. But if you didn't know there were 8 pints per gallon, you wouldn't have been able to answer this one. So try to study some of the very basic measurements. They may show up from time to time. All right, question 14. Question 14 says, if a car travels 360 kilometers in 5 hours, how many kilometers will it travel in 9 hours when driving at the same speed? So the last one, or 2 problems ago, we were asked to find the average speed. This one is asking us to find how far or the distance it will travel given a certain rate. So we are going to have to use the distance formula to solve this one. In fact, we're going to have to use it twice. We're told that it travels 360 kilometers in 5 hours. That said, it never gives us the rate of speed of its travel. So let's go ahead and set this up. Again, I told you we're going to have to use it twice, and I'll show you why in just a second. Let's plug things in accordingly. We're told it travels 360 kilometers, which is distance. And it does that in 5 hours, so we don't know what the rate is. but we know the time is 5. And again, distance equals rate times time. D stands for distance, R stands for rate, T stands for time. You can see that I plugged distance for D. I didn't know the rate, so I left that blank, or I left that as R, and T, where we're told 5 hours. Now I want to find out how fast this car is traveling, so I'm going to solve for R, or rate, which means I'm going to have to divide both sides by 5. Cross this out. This leaves me with 360 divided by 5. And again, we can regard all fractions as long division. This is 360 divided by 5. 5 goes into 36 7 times without going over. 5 times 7 is 35. 36 minus 35 is 1. Drop down this 0. 5 goes into 10 2 times. 5 times 2 is 10, so we can see there's no remainder, which means that given this distance and the time in which it covered that distance, we know it's traveling at a rate of 72 kilometers an hour. And now let's look at the second part of this problem. How many kilometers will it travel in 9 hours? So we want to know the distance. So I'm going to leave distance as D. I know the car's traveling at 72 kilometers per hour, and we're told the new time is 9 hours. So this problem simply becomes a multiplication of two whole numbers, namely 72 times 9. 9 times 2 is 8. 18, carry the 1. 7 times 9 is 63, plus 1 is 64. Therefore, we know the answer is 648 kilometers. Okay? So to do this one, you had to figure out what the rate of the car was. And then you had to use that information to figure out how far it would travel in 9 hours. So you basically had to use 2 iterations of the distance formula, and in both cases you had to identify what you had and what you were trying to solve for. So kind of a difficult problem. You will see a question regarding distance, rate, and time on the ASVAB, so make sure you know how to manipulate this formula accordingly. Okay? Let's go ahead and move on to question 15. All right, question 15 said Maya purchased a boat for $18,340. Its value depreciated by 15% in the first year she owned it. What was her boat worth at the end of the first year? So I already introduced a formula you can use when dealing with these percentages, namely this one. Percent change equals final amount minus original amount over original amount times 100. Okay? You could use this formula to solve this one and get the answer pretty easily. That said, all I'm going to do is take 18,000, multiply it by 15%, and then subtract whatever that amount is from 18,000. So let's go ahead and do that. I think that's a little easier, an easier way to approach this problem. 18,000 times 0.15. Again, 0.15 represents 15%. We're multiplying a whole number by a decimal. We can't do that. Before we do that, we have to shift the decimal place accordingly. I'm going to shift this 1 2 times, and at the very end of the problem, I'll shift those decimal places back into the left. So in reality, I'm doing this. Let me do it over here. 18,340 times 15, albeit with 2 decimal places to shift back in at the end. So let's work this out. 5 times 0 is 0. 4 times 5 is 20. Carry the 2. 3 times 5 is 15. 16, 17. Carry the 1. 5 times 8 is 40. Plus 1 is 41. Carry the 4. 5 times 1 is 4 plus 5 times 1 is 5 plus 4 is 9. Add a 0 before we start working with this 1. 1 times 0 is 0. 1 times 4 is 4. 1 times 3 is 3. 1 times 8 is 8. 1 times 1 is 1. Let's add. 0 plus 0 is 0. 0 plus 0 is 0. 7 plus 4 is 11. Carry the 1. 3 plus 1 is 4. Plus 1 is 5. 9 plus 8 is 17. Carry the 1. 1 plus 1 is 2. Shift R, decimal place in 2 times to the left. 1, 2. So we can see that the amount by which the value of the boat decreased was $2,751. That said, the question is, what was her boat worth? So what I got to do, or what we have to do, is take this 18,340, subtract out the amount by which it depreciated, which was 2,751, and then we'll get our final amount. 0 minus 1 we can't do. We have to borrow. This becomes 3. This becomes 10. 10 minus 1 is 9. 3 minus 5 we can't do. We have to borrow. This becomes 2. This becomes 13. 13 minus 5 is going to be 5, 6, 7, 8. 2 minus 7 we can't do. We have to borrow. This becomes 7. This becomes 12. 7, 8, 9, 10, 11, 12. So this is 5. 7 minus 2 is 5. 1 minus nothing is 1. So we can see that after depreciating in the amount of 2,751 over the course of a year, her boat would now be worth $15,589, which is right there. Okay, if you wanted to plug it into this formula, it would absolutely work, but it would be a lot more work. So just bear in mind that this formula will always work. You can take a look at that video I created to see that that is in fact the case. But in this case, we know that we're just taking 15% away from 18,340, and the math's fairly simple to do. So that's that one. And number 16, our final question. Hopefully it's easy. And it's not. All right. 16 says the radar system beeps once every second. How many times will it beep in 3 days? So in this case, I'm going to go from days to hours to minutes to seconds. I'm going to have to make all those conversions. This one's fairly easy. We're going from 3 days. There are 24 hours in a day. So in 3 days, that's going to be 24 times 3. 4 times 3 is 12. Carry the 1. 2 times 3 is 6. Plus 1 is 7. So in 3 days, that's the equivalent of 72 hours. Okay? So we made our first conversion, days to hours. Now we got to go from hours to minutes. Well, we all know there are 60 minutes in an hour. So to figure out how many minutes there are in 72 hours, I got to take 72 and multiply that by 60. 2 times 0 is 0. 7 times 0 is 0. Add a 0 before we start working with this 6. 6 times 2 is 12. Carry the 1. 7 times 6 is 42. Plus 1 is 43. Let's add. We can see 0 plus 0 is 0. 2 plus 0 is 2. 3 plus nothing is 3. 4 plus nothing is 4. So I've made this conversion from hours to minutes, namely it's 4,320. And to make the conversion now from minutes to seconds, we have to realize there are 60 seconds in every minute. So I'm going to have to multiply this by 60 again. So I'm going to do 4,320 times 60. Again, take your time when you do this. You don't want to make a simple mistake. 0 times 0 is 0. 0 times 2 is 0. 0 times 3 is 0. 4 times 0 is 0. Add a 0 before we start working with this 6. 6 times 0 is 0. 6 times 2 is 12. Carry the 1. 6 times 3 is 18. Plus 1 is 19. Carry the 1. 6 times 4 is 24. Plus 1 is 25. Let's add. Again, there's nothing to add in the top row. So 0 plus 0 is 0. 0 plus 0 is 0. 2 plus 0 is 2. 9 plus 0 is 9. 5 plus nothing is 5. 2 plus nothing is 2. Add a decimal every third number, and we can see that the total number of seconds the radar system beeps, if it beeps every second in a 3-day period, would be 259,200. Again, if you make this little chart up here, and you know there are 60 minutes per hour and 60 seconds per minute, should be fairly easy to do, as I just showed you. But that's all I have for you in this video. If you found this video helpful, feel free to give it a thumbs up and leave some positive feedback in the comments section below. In addition, feel free to subscribe to my channel. I found some other practice tests I'm going to make videos like this on. So again, if you found it helpful, feel free to subscribe. But on that note, I'm going to go ahead and cut you loose.
Konnichiwa.